solving inequality. Before go through this section, I would recommend you to review solving simple equation, polynomial, and rational equation. So let's get started. Let's start with solve this simple inequality. Solve the inequality, express your solution in interval notation, and sketch the solution set. 4 minus 3x less than or equal negative 1 plus 8x. We will solve the inequality as follows. We would distribute the negative 1. We will collect all the terms that have the variable on one side and all the constant terms onto the other. So now, let's start with sketch the solution set. We want, on a number line, see here's your negative 1. We want the value of x to be less than or equal to negative 1. But when we include the value of negative 1 and everything before that. So that is the solution set when you sketch it. In interval notation, everything that is less than negative 1 up to negative 1 is the solution of the inequality. Part B. I will start part B by first multiply each of the factor with the least common denominator. The least common denominator of 2, 5, and 4 is 20. So I multiply each of the terms by 20. To get now I would distribute the 4. With inequality, when I adding or subtracting to one of the term, I have to do it to every one. So here, let's go ahead and minus 15 to all three sides. Here we divide by negative 12 to all of them. And when we divide by a negative number, the side of the inequality change. And let's simplify the fraction. Let's take a look at the solution set on a graph, on a number line. So 11 over 12 and 13 over 6. We want everything in between. And so in the interval notation, that is 11 over 12, 13 over 6, including the both endpoint. So let's talk about solving nonlinear inequality. So the previous two examples is linear inequality, then that graph on the number line that you can see is simple. But in the next couple of problems, we're looking at nonlinear inequality. So let's talk about the side of a product of a quotient. If a product of a quotient have an even number of negative factors, then its value is positive. So what does that mean? So for example, you look at negative 3 times negative 2. So the number of the negative factor here is 2. That is an even number, so the product here is positive. Whereas if it have a negative factor of negative, so say negative 3 times negative 2 times negative 1, so have a odd number of factor of negative, this result to be negative 6. And keep that in mind, we will be using that for the next couple of problems. So guideline for solving nonlinear inequality. First, we move all terms to one side so that one of the side of the inequality is 0. Simplify the other side. Factor the non-zero side of the inequality. Find the interval. Make a table of value. And create a test value to determine the side of each factor. Then use the side table to find the satisfied interval of the problem. So let's take a look at our first example. Solve the nonlinear inequality and express your answer in both interval notation and graph the solution set. So x squared minus 3x minus 18 is less than or equal to 0. So here noted that everything already on one side of the equation and the other side is 0. Then nothing else we can do. So let's start. So first, we want to solve this equation. We will solve x squared minus 3x minus 18 equal to 0. We will factor this equation using the AC methods. So if you don't remember what is the AC methods for factoring quadratic equation, you may want to review that. Factor this, we get x minus 3. Factor this, we get x minus 6 times x plus 3. This means x equal to 6 or x equal to negative 3. And these are the critical value or the value in our table. So now we will create an interval and make the test point. So on the number line, here we get negative 3, negative 6. So we look at 3 interval. That is negative infinity to negative 3, negative 3 to 6, and 6 to infinity. So note that here we have a less than or equal. So each of this interval here, we want to include the endpoint. So let's choose the value for the test value in each of this interval. So in the first interval, let's choose x equal to negative 4, x equal to 0, and x equals 7 here in this case. So I will test each of this interval. Okay. So let's start with the table. And place each of the factor into the table. So x minus 6 and x plus 3. So then the result then in the end here is the factor of x squared minus 3x minus 18. So in our first interval, we are looking at negative infinity to negative 3 included, negative 3 to negative 6 included, and the last interval is from negative 3 to 6 here, and from 6 to infinity here. we will use each of the test points to test each of this interval. Okay. In the first interval, when x equal to -4, -4 minus 6 equal to -10. So note that the first interval, the first factor is negative. And the second factor, -4 plus 3 equal to -10. So this is negative. So from the interval from -infinity to -3, these two factors, x minus 6 and x plus 3 are both negative. So the resultant is positive. Okay. Similarly, I have x equal to 0 for the second interval. So 0 minus 6, we have negative. 0 plus 3, here we have a positive. So the resultant here is negative. In the next interval, 6 to infinity, we have positive, and then positive. So note that we want to find the inequality that is less than 0. So this is the suitable solution set. So then here we get the solution in interval notation. It's from -3 to 6. And the graph, -3 to 6, including the two endpoints.